Hello and welcome back to our subject, Digital Technique Fundamentals. Our discussion today is about binary number complements. Now, if you notice that in our last discussion, which is binary arithmetic, specifically in addition and subtraction, I did not provide you with an example wherein after adding numbers or subtracting numbers, the result is a negative value. Okay? Or it has a negative value. Okay? Because it cannot be done basically using the binary addition or subtraction. So we need to use another type of method in subtracting or adding numbers which results into a negative value, and that is using the binary number complements. Now, there are two binary number complements. One is the 2's complement and the other one is the 1's complement. Okay? So let's make use of the 2's complement first. For the 2's complement, this is the rule, no? Every 1 in the number is changed to 0 and every 0 to 1. Okay? A 1 is then added to the least significant bit LSB of the number form. Alright? So again, this is the rule for obtaining the 2's complement. Every 1 in the number is changed to 0 and every 0 to 1. A 1 is then added to the least significant bit of the number form. Okay? Example, we have 1, 0, 1, 1, 0, 1 of base 2. The 2's complement of this number will be, again, every 1 is changed to 0 and every 0 changed to 1. Okay? Okay, so this is the equivalent of this one. 1, 0, 1, 1, 0, 1 will become 0, 1, 0, 0, 1, 0. And then it says a 1 is then added to the least significant bit of the number form. Okay, so this will be 1, 1, 0, 0, 1, 0. So this becomes now the 2's complement of this particular number. So how do we use the 2's complement in adding or subtracting a negative number? Or a negative number. So I say example, let's say we want to add minus 23 of base 10 plus minus let's say 19 of base 10. Okay? So this is for addition. Adding two negative numbers using the 2's complement. So first is to convert this into its 2's complement equivalent. Okay? So by the way, in 2's complement addition or subtraction, only negative numbers are to be complemented. Alright? So I will have an example of that later. This one here, we can use this as our example. Okay? So, what is minus 23 in binary form? By the way, we will be using the 8 bits. No? in this particular discussion. So, minus 23. So, again, we make a series of 8 ones because we'll be using 8 bits. So, again, this is 1, 2, 4, 8, 16, 32, 64, and then 128. So, what is minus 23? You have 0, 0, 0, 1. Okay, that is 16. So, 16 plus 8 is 24, more than 23, so you make the 0. 16 plus 4 is 20, 22, 23. Alright? So, the equivalent of 23 in binary form is 0, 0, 0, 1, 0, 1, 1, 1 of base 2. How about 19? So you have 0, 0, 0, 1, okay? 0, 0, 16 plus 2 is 18, plus 1 is 19. So the answer here is 0, 0, 0, 1, 0, 0, 1, 1 of base 2. So if you notice that both numbers are negative numbers. So we have to obtain the 2's complement of these two number. Okay? So you have minus 23, and that is this one. This one here is positive 23, and this one here is positive 19. So we want to obtain the negative equivalent of 23 and 19. So we obtain the 2's complement of this particular number. Okay? So for this one here, what will be the 2's complement? Equivalent? So this becomes 1, 1, 1, 0, 1, 0, 0, 0. Right? Then it says a 1 is then added to the least significant bit of the number form. So this becomes 1, 0, 0, 1, 0, 1, 1, 1. Okay, so this is now the 2's complement of this particular number, or 23. So in other words, this one here is the equivalent of a minus 23 in binary form. So you have 1, 1, 1, 0, 1, 0, 0, 1. Okay? Then, 19. This one here. So what is the 2's complement equivalent? So you have 1, 1, 1, 0, 1, 1, 0, 0. Sorry. Then, 1 is added to the least significant bit of the number form. So this becomes 1, 0, 1, 1, 0, 1, 1, 1. So this is now the 2's complement equivalent of this particular number. Sorry. Okay, so we write this here. So this becomes 1, 1, 1, 0, 1, 1, 0, 1 of base 2. Alright? Now, both numbers now are being complemented. So in other words, this will now becomes, so when you say complement, what is the complement of minus? That is plus. The complement of minus here again is plus. So this one, this becomes plus na siya, no? Okay? Then we simply add the two numbers. So this becomes 1 plus 1 is 0, carry 1, 1, 1, 0, carry 1, 1, 0, carry 1, 1, carry 1, 1, carry 1, bring down 1. Okay? In this particular case, the n around carry is not used. Okay? So, and around carry is not used. So in other words, your final answer will be this number, base 2. Now, if you notice that the most significant bit, which is this one here, is actually the sign of the number, no? This is the sign of the number. In this particular case, if the sign is 1, then that means that it is a negative number. If the most significant bit is 0, then the value or that number is a positive number. So in this case, since the value here, the most significant bit is 1, then the value or this value here is a negative number. Okay? Now, how do we know that this one here is the negative number of the answer here? Okay? So let's add. 3 and 9 is 12. Carry 1. That is 42. Negative 42 of base 10. So this one here, is this equivalent to minus 42? That is a question mark. So how do we obtain, how do we know that this number here is a negative 42? So for checking purposes, okay, so the number here, in order for us to check whether this number here is a negative 42, all we have to do is again to obtain the 2's complement of this particular number. Because the complement of minus 42, as we know, is positive 42. So if obtaining the complement of this should result into a positive 42. So we just obtain the 2's complement number. So this becomes what? 0, 0, 1, 0, 1, 0, 0, 1. A 1 is then added to the least significant bit of the number formed. You have 0, carry 1, 1, 0, 1. 0, 1, 0, 0. So if you notice again that the most significant bit is a 0 number, that means that it is a positive number. It is a positive number. So how do we know that this one here is 42? So you have 1, 2, 4, 8, 16, 32. Okay? 32 plus 8 is 40, plus 2 is 42. Positive 42. So if this is positive 42, that means that this one here is negative 42 equivalent in binary form.